So today we will continue with the system of linear equations with the second different method for solving them. Today we will see the substitution method. What is the idea of the substitution method? The idea is to isolate a specific variable. We need to define which one. We can decide either both different variable that we have. We will isolate that one on one equation. You can decide also if you want to do it on the first or in the second one of the system. And after that, we will substitute that specific value that we have isolated on the other equation in order to, after being substituted, we will have one linear equation with one only variable and we will be able to solve it. As always, we can do the verification process on the original equations. Remember, always, if we are doing the verification process, we need to do it on the original equation. So let's see. On the first exercise that we have, I will decide that I will isolate the m on the first equation. So it's going to be 2m equals 1 plus 3n. And after that, it's going to be m equals 1 plus 3n, all of it divided by 2. So I have isolated the m. We can substitute that value of m in the second equation, and it's going to be 2n plus 4 that multiplies the value of m that we have the value of n, 1 plus 3n divided by 2 equals 4. After that, we can check that here it's going to be 4 divided by 2, it's only 2, so it's going to be 2n plus 2 that multiplies 1 plus 3n equals 4. So it's going to be 2n plus 2 plus 6n equals 4. It's going to be 8n plus 2 equals 4. 8n equals 4 minus 2. 8n equals 2. N equals 2 divided by 8. We can simplify our answer. N equals 1/4. We have already the value of n. How to get the value of m? Of course, we can use this specific formula where we have isolated the m. So it's going to be m equals 1 plus 3 that multiplies n, that is 1/4. All of it divided by 2. So it's going to be m equals 1 plus 3/4, because remember it's having a 1 here. All of it divided by 2. It's going to be m equals, we need to have the same denominator in order to add 1 and 3/4. So it's going to be 4/4 plus 3/4. M, it's going to be 7/4. All of it divided by 2. This 2 has a 1 as a denominator, so we need to multiply the corners and the middle numbers, and it's going to be m equals, because it's a fraction divided by a fraction, so it's going to be 7/8. So we have already our answer that m equals 7/8, n equals 1/4. Remember, we can put our answer in that way, or we can put our answer also in coordinates. In this case, we don't have x and y. Remember, when we have x and y, is first the x, then the y. So normally, if we use coordinates with other letters, we respect the alphabetical order. So it's going to be m, comma, n. So our answer in coordinates is going to be 7/8, comma, 1/4. So let's see how to do the verification process of this specific one. Remember, we need to do the verification process on the original equation. So let's see the verification process for exercise 1. So on exercise 1, it's going to be 2 in the first equation that multiplies m 7/8 minus 3 that multiplies 1/4 equals 1. So this one is like having a 1 here and having a 1 here. So it's going to be 2 and 8. They can be simplified, and it's going to be only 7/4 minus 3/4 equals 1. It's going to be 4/4 equals 1. 1 equals 1. So we have verify on the first equation. Let's verify our answers in the second equation. It's going to be 2 that multiplies n 1/4 plus 4 that multiplies 7/8 equals 4. So it's going to be 2 and 4. They can get simplified, and it's going to be only 1/2. Let's see the other one. We can also simplify 4 and 8, and it's going to be plus 7/2 equals 4. It's going to be 8/2 equals 4. Then we will have 4 equals 4. We have verified our answer on the two original equation. So we have done specifically the verification process for this first exercise. Let's see another exercise. So in this second exercise, it's going to be almost the same. We need to isolate a letter on the first equation, then put it on the second equation, substitute it. So let's see. I will isolate the x on the first one, so it's going to be 8x equals 6 plus 12y. So it's going to be x equals 6 plus 12y over 8. Of course, maybe we can simplify the x, but actually if you use that one, you will get also the correct answer. But in this one, of course, we can simplify it. I will do it. X equals, on the top part, we can take a number 2, and it's going to be that multiplies 3 plus 6y divided by 8. So we can simplify this 2 and this 8, and it's going to be a 4. So x equals 3 plus 6y, all of it divided by 4. So we can use either this one or this one to substitute in the second equation. Let's see. If I substitute in the second equation, it's going to be 6y minus 4 that multiplies x, that it's 3 plus 6y over 4 equals 3. So it's going to be 6y minus 4 and 4, they can get simplified. So it's going to be only minus 1 that multiplies 3 plus 6y equals 3. It's going to be 6y minus 3 minus 6y equals 3. So we will get like 0y equals 3 plus 3. 0y equals 6. That means there is impossible to be 0 multiplied by something to gives me 6. So in this case, since there is not a value specific for y, we can say that this system has no solution. Or we can say also that x comma y belongs to an empty space. Why? Because it's impossible for x and y to have a specific value, since we have 0 x or 0 y equals a number. It's impossible to have it. So this is why in this one, the specific solution is that the set or the equations we have no solution, or x comma y belongs to an empty space. Let's see another example. So let's see, in this third example, it's going to be something like this. On the first equation, we can isolate a specific letter. I will isolate x, and it's going to be 7x equals 6 plus 2y. That means x equals 6 plus 2y, all of it divided by 7. So I have already isolated the x. If I substitute the value of x in the second equation, it's going to be 21. That multiplies x, that is 6 plus 2y, all of it divided by 7, minus 6y equals 18. 21 divided by 7, it's only 3, so it's going to be 3. That multiplies 6 plus 2y minus 6y equals 18. It's going to be 18 plus 6y minus 6y. It's going to be 18. It's going to be 6y minus 6y equals 18 minus 18. We will get 0y equals 0. So every number multiplied by y, it will be 0. So in this case, we can say like, because every number multiplied by y is 0, y can have any value. That means x can have also any value. So we can set infinite set of solutions. Or infinite solutions. Or we can set also that x comma y belongs to all the real numbers. Or we can put it like also something like x belongs to a real number, and also that y belongs to a real numbers. So we can put, maybe by text is easier here, we can say like x and y, they all be all the possibilities, so we will have infinite set of solutions for this specific question or set of equations. Let's see one last example. So on this one, we have those equations. They look like super difficult because we have x, y many times. So the idea is first to simplify our equations in order to have only x, y, and a number like the other ones. So let's see how to do it. On the first equation, in equation number 1, it's going to be x minus 3. Well, we can multiply all the equation by 3 because we have a fractionary equation, and it's going to be 3 that multiplies x minus 3 plus 2 that multiplies 9 minus y equals 3. So it's going to be 3x minus 9 plus 18 minus 2y equals 3. So it's going to be 3x minus 2y equals, and it's going to be 12 because it's going to be, let me put it all complete, it's going to be 3 minus 18 plus 9. So it's going to be 3x minus 2y equals, and it's going to be here minus 6. So this one will be my first equation. Let's see the second equation. It's going to be, for the second equation, it's going to be the multiplication for x squared minus 1, because first we have here what it's a product of the sum and difference of a binomial. It's going to be minus 4xy minus 2y plus y squared equals, and in the other side we have a binomial squared, and it's going to be 4x squared minus 4xy, that is 2 times the first one multiplied by the second one, plus the second one squared. What will happen? 4x squared will disappear, minus 4xy minus 4xy, y squared and y squared, so we will get minus 1 minus 2y equals 0. So we can isolate from here the y already and get an answer, because it's going to be minus 1 equals 2y, y equals minus 1/2. So we have already the value of y. We can substitute that value of y in our first equation that we have here. 3 that multiplies x minus 2 that multiplies minus 1/2 equals minus 6. So it's going to be 3x minus multiplied by minus, it's plus. The 2 and the 2 gets eliminated. So it's going to be plus 1 equals minus 6. So it's going to be 3x equals minus 6 minus 1. 3x equals minus 7. X equals minus 7/3. And we have already our answer. Isolated, x equals minus 7/3, y equals minus 1/2, or we can put it in coordinates. Remember, always x comma y. So it's going to be minus 7/3 comma minus 1/2. If we want to know where in the in a graph it will be, it's going to be minus 1/2. It's going to be here's. If here's the 1, it's going to be at the middle, minus 1/2, minus 7/3. 7 over 3 is like 2 point something, so it's going to be here. So here is where all both equations will cross, and that will be the specific point that it's the solution for our substitution method. Let's see one more example for those that have any type of questions. So in this specifically, we will isolate the n on the first one, and it's going to be n equals minus 1 minus 5m. So we can substitute that value of m on the second equation, 3m plus 2 that multiplies minus 1 minus 5m equals 5. So it's going to be 3m minus 2 minus 10m equals 5. Minus 7m minus 2 equals 5. Minus 7m equals 5 plus 2. Minus 7m equals 7. M equals 7 divided by minus 7. M equals minus 1. We have the value of m. Here we can get the value of n. So it's going to be n equals minus 1 minus 5 that multiplies the value of m minus 1. N equals minus 1 plus 5. N equals the value of 4. So we have the isolated answer, m equals minus 1, n equals 4. We can put it in coordinates. Remember, we will respect the alphabetical order. So it's going to be m minus 1 comma 4. That will be our answer. So now, how to do the verification process of this one? We need to use the original equations. So let's do the verification process on the original equations. So for the verification process, it's going to be 5 that multiplies m, that it's minus 1, plus n, that it's 4, equals minus 1. So it's going to be minus 5 plus 4 equals minus 1. Minus 1 equals minus 1. So this one is correct. Let's check the other one. It's going to be 3 that multiplies m minus 1 plus 2 that multiplies n, that it's 4, equals 5. So it's going to be minus 3 plus 8 equals 5. 5 equals 5. So yes, it applies. So we have done the verification already for this specific example. So that was all for substitution method. We will see each other on the next system of linear equation solving method.